turned this whole thing around in about 6 to 7 months, which was a lot of pressure on both us and HOF.
The original lighting rig, of course, mostly being tungsten, they were lightweight fixtures, and the structures that they were hung from were very heavy. They were made of steel. And with the brand new modern LED equivalents that we have now, they are much heavier, the lights themselves, with all the switch mode power supplies and things like that. So we needed to take the weight out of the structure and into the lighting fixture.
So the main challenges we had was we have existing winches here that have a limited load capacity on them. We wanted to find the structure that would have the capacity to lift the new rig, but also be light enough to be lifted by our winches. That's where we actually turned to HOF and asked for some help. Here at the Royal Ballet and Opera in London, we have up to 285 performances throughout the year, and we have the same amount of rehearsals. Our lighting battens are used constantly from 7 AM to 11 PM at night. So it's a really busy season, and then we get 3 weeks of maintenance in the summer, and then everything needs to be working beginning of September for the new season. And that's our only point where we can do any project work and swap out any structures, infrastructure. Everything that we design has to be something that works straight away.
Our first impression during our initial on-site visit here at the Royal Opera House was simply overwhelming. All 5 battens had to be completely replaced with a lighter aluminium construction as they were too heavy, and the suspension points did not have sufficient load-bearing capacity for the new heavier lighting technology in combination with the old batten. One of the technical challenges was that the suspension points could not be moved, and they just have a load capacity of 420 kilograms per host. We were also not allowed to increase the overall height of the new batten construction. So in order to comply with the specified construction height, the best and simplest solution was to integrate the energy chain into the top truss.
So the top truss, we call it the Mother Truss, is responsible for the load-bearing capacity.
The Mother Truss is a special truss based on the MLT4, which is open at the top. This means that approximately 70% of the height of the energy chain storage system now fits into the truss. A total of 5 battens, each 21 meters long, were installed, consisting of a Mother Truss and a Bottom Truss, which are connected to each other by a special construction. Each batten has 3 units that can be moved individually. The Bottom Truss is a mixture of MLT3 and HOFFORK 355 concepts. Both truss systems are connected by a special developed construction, which serves to hold border and working lights, but can also be used as a cable gangway. The Bottom Truss can be moved out of the load and placed on a total of 50 MLT dollies without having to dismantle the entire structure or overload the dollies with the weight of the entire structure. This can enable short-term modifications to lighting setups, for example. By renewing the battens, the dead weight of the 5 battens was reduced by around 1/3 to approx 5.3 tons. This reduction naturally benefits the new payload capacity of up to 15 tons. At the same time, the height of the structure was reduced from 4.7 meters to 4 meters. The structure can be moved vertically over 25 meters in height. A total of around 9 tons of energy chains were installed with a total length of over 1 kilometer.
So we knew the window that we had to complete this installation on stage, and that's August. We've got 4 weeks. I think it was back in May we had a prototype. So it was great that we could go see the prototype, recommend the changes that we want, see the changes that we want, and then get it all delivered in August. So we received our first delivery from HOF in Aberdare, and that was the Mother Trusses. So the Mother Trusses, we installed the energy chains in them, so that was all prepped in advance. Once they were complete, they got shipped over to Covent Garden. Then we were in the first week of our maintenance period in August, and those were the first things that got rigged onto the winches. From the last week of July leading into August, we'd received all of our structures from HOF, rigged all of our lights onto the pre-rig truss, and we were focused on the actual rigging, getting everything up in the air. So we had our winches ready, upgraded, commissioned, and we started lifting the Mother Truss, the energy chain, out to the grid. Once all that was done, we were building the frame section, which is in the middle, and then we were picking up the pre-rig truss. That was all happening within about 2 weeks. And here we are at the end of August, and it's all installed and 0 complaints.
We were particularly taken by the fact that the products from HOF are aimed at the end user, being the lighting technician. So, you know, the accessories, the T-bars, the dollies, all of those things massively improve our day-to-day operation, but particularly our maintenance periods.
So the best way to describe HOF was collaborative. They never said no to us. They always looked at the problems and found solutions. They'd redesign, draw something and send it out within a week, and have a solution to every problem that we threw their way. And that's why we've been able to achieve what we've achieved in 6 months.